Hi all, I wanted to make a video going over the solutions for the free response questions from your AP exam this week. So here goes. These are not my solutions. They were posted on the College Board website by one of the other AP SAS teachers. So first question, you're doing a 5-number summary. So you could do it by hand, but calculator makes more sense to me. Plug the length of stay in list 1 and the number of patients in list 2, and then run one variable statistics with your frequency as list 2. And then your 5-number summary is going to turn out to be this. So I think that might on its own get an EP or I right there. I'm going to say if you have 3 or more right, I'm going to guess that's a partial, like 3 or 4 is a partial, 5 is essentially correct. I don't think you necessarily need to show any work for that. Okay, moving on to part B. They wanted you to use the outlier rule. So for the outlier rule, now hopefully you just made up some quartiles if you didn't have an idea on how to do part A, and you could get an essentially correct for this potentially. So it's just quartile 1 minus 1.5 times the IQR, and quartile 3 plus 1.5 times the IQR. So there's no low outliers and there's 2 high outliers. 12 and 21 both fall above this threshold of 11. So I think this is going to be clumped together potentially with part 2. With the low outliers, they're taking the mean, which you'd have to get from doing your one variable stats. Again, make up a mean, make up a standard deviation, and if you do that correctly, then I think you can get some credit here. So there was one high outlier. So for this part, I think they're going to grade these combined. So if you got one part correct and the other part not correct, that would be a partial. Both parts correct would be essential. And then let's look at part C. Oh, they told you the mean and standard deviation. Okay, even better. Sweet. Part C, explain why method A might identify more data points. So looking back at the work, these numbers aren't as extreme as these. So that would be one reason potentially why there's going to be more numbers that are less than 3 and greater than 11 than this. Also, you have a distribution that is skewed to the right. So you're going to have some points to the far right. And what does he say? These points won't affect the IQR since they'll be greater than core 3. Okay, so that makes sense. So they're not increasing the IQR, but they are increasing the standard deviation. So that's why you're going to have more outliers for scenario 1 versus scenario 2. I think there's a couple things you can argue he went pretty detailed, but this is going to be essentially correct, partially correct, or incorrect. So I think you're going to get 3 parts here. EP or I is a 2. Can you get to a 2 somehow? Okay, moving on to question 2. This is your experimental question, or your collecting data question. So a year-long investigation, walking cholesterol levels. They will select a random sample of 100 adults. One aspect is to record the number of miles that they walk each day. They're deciding if they should wear an activity tracker or keep a daily journal. Describe what bias could be introduced by keeping the journal instead of wearing the activity tracker. So he's saying response bias, people relying on people to accurately record their mileage has several issues. They know you're supposed to walk more for exercise, so they might lie. So that's going to result in an overestimate of the true distance that they walked. Okay, that's one option. There's other options that you could argue, but you had to come up with both a type of bias and then is it going to result in an over or an underestimate. So if you did a type of bias and didn't do the overestimate and it's reasonable with an explanation, I'd say that would be partially correct. Okay, part B, they're going to have their cholesterol measured each month and they're going to perform a significance test at the end and look at the average cholesterol level for subjects who walk fewer to see if that's greater than those who walk more. So selecting a simple random sample creates reasonable representation of the sample of the target population. Explain the benefits of using a representative sample. Well, that's going to allow us to generalize the results. So selecting a random sample, conclude that the mean cholesterol level for those who walk less is greater than those who walk more, assuming they find a difference. So without a representative sample, there's a possibility of some other variable leading to a significant result. Okay, I think that's kind of talking about what I am. I didn't go down the confounding route. To me, that's not the random sample piece. To me, it's being able to generalize to that larger target population because those subjects are representative of that larger population. Okay, part C, suppose the researchers conduct the test and find significant results. Would it be valid to claim? No. Nope. This is association does not prove causation because of confounding of X. This is not an experiment. There was no random assignment. It's just an observational study, so no. So again, 3 parts. I'm thinking EP or I is going to get you to 2. So you have that option there. That's what you're looking at.